Okay, so this is a review for a few of us that just seem to go the wrong way a little bit on the test. I want to give you one more shot at it because you seem to be understanding that the jump was 3 decimal places or 6 decimal places. You just got confused as to whether to go to the left or right. So I want to just clear up a few things. What you need to do is look at this conversion table, which is what you're given, and it's a little bit different than the one you use, but it's still very, very similar. I want you to look at it and envision the things. So milligrams, those are little tiny drops of sand. And grams, that's a little tiny, tiny weight. And then when you think of a kilogram, well, now you're getting into a little bit bigger of a weight. It's fairly heavy. And a ton is a truck. Ton is something quite heavy. And I'll put a baby elephant, a really bad baby elephant here. All right, some legs. Anyhow, baby elephant. Now, you have to envision the same when you look at the next line. When you're looking at a milliliter, that's simply just a small drop of water. And a liter, picture it as the liter of milk that you drink at your house. And a kiloliter is hard to imagine because we haven't seen a kiloliter really before. But it's basically a great big box that is 1 meter by 1 meter by 1 meter. And it's a great big box of liquid. Lastly, when we do our volume, we know that a centimeter cube, and again my board is off just a little bit, so it's going to be hard to draw these very well. A centimeter cube is small, a decameter cube is a little bit bigger, and a meter cube is quite a bit larger. Anyhow, very hard to draw when the board is not cooperating. But you get the gist. That these are getting units from smaller to larger. And when you make your conversions, you have to understand that I'm going from a smaller to a bigger, so what will happen to my number? So if we look at our first example here, the first part of the test was just having you convert mass quantities. So all you're really looking for in the first question is this line right here. And you know there is 1,000 of each of these in each of these holes. So when you convert, you're using the number 1,000. And if we are going to convert milligrams to grams, we're going to go from here to here. And if you have just a few milligrams, if you have 4 milligrams, 4 tiny grains of sand, and we have to use the number 1,000 to multiply or divide, having 4 small little milligrams of sand turn into 4,000 grams, things that are bigger, does not make sense. So to multiply this number does not make sense. Only dividing 4 by 1,000 makes sense. And of course you take the 4 and you go 2 decimal places or 3 decimal places total, and the answer is 0.004 grams. When you're doing this last one here, you have 645 kilograms, and that's right here. And if you are going to grams, you have these big weights, and you're going to go into smaller units. So it only makes sense when we break that kilogram unit up into something smaller, you're going to have more of them, because grams are smaller and there are more grams in a kilogram. So this time we're going to multiply by 1,000, and that means we add 6 zeros or remove the decimal place 6 places to the right. This board is incredibly horrible. I'll try to fix it in just a second. So that would be 645,000 grams. Okay, so hopefully the board is a little bit better. Now the next question had is you're going to convert all units of capacity. So we're going to go from kiloliters to liters in this first question. And kiloliters are this big, large container right here. And we are going to see how many of these smaller 1 liter containers will go in it. Again, we know that the number is 1,000. that is between there and there. So what you have to think logically is if I have these great big containers called kiloliters, will I have more liters or less liters? And of course you'll have way more of these smaller boxes. We know that the decimal is 3 places, so we're going to multiply in order to make it larger. We're going to multiply 4 kiloliters by 1,000. 4 kiloliters is 4,000 liters. It doesn't make sense to say you have 4 kiloliters and that would be decimal 004 liters. When you think of the size and think of the picture, logic says I can't even put that answer. Anyhow, my next one here is milliliters, and I'm going to take it to liters. Please remember that a milliliter is just a little drop of water, and a liter is that 1 liter box of milk that you have. And if I have 34 milliliters, we know that those drops are just going to go in the very bottom of a 1 liter container. It's not going to make 34,000 liters. It is going to be a smaller number, and we know it's only 1 jump, so we're going to divide by 1,000, and that would be decimal 034. All right. This next one is we are going to move volume around, and again you have to picture what we're talking about, and that's this row right here. And if we had 234 of those little small centimeter cubes that we talked about and showed each other in class, the little tiny Lego pieces, and then we tried to put them into that big decameter, the larger decameter square that I had cubed, we know that 234 wouldn't even fill up 1 decameter cube. They won't fill it all the way to the top, so there is no way we can say that this will be 234,000. We can't multiply by 1,000. When we're going from centimeters to decameters, it'll be a smaller number we have to divide. And when you divide by 1,000, when you divide 234 by 1,000, it's just 3 decimal places to the left. Use your calculator if you like. If that's messing you up, by all means. Many of you might have even known you were dividing and then just went to the right by mistake. I'm not quite sure what was going on. But logic says there's no way I can have 234 of these small little centimeters and have 234,000 of these larger cubes. They just don't convert to the same amount of volume. Anyhow, and this next one is decameters to meters cubed. It's very same. It's 1 jump. If I have 4.5 decameters and I'm getting bigger into a bigger unit of meters cubed, I can't make this like a smaller number. 4.5 decameters we're going to divide, and that will give us, let's see, 3 places, 0, 0, 4, 5 meters cubed. All right, and lastly, because I don't want to belabor too much time, I think the people that didn't do so well on this, you were just having a mind cramp, and once you started it, you'd finished it the whole way, the whole time. Here it is. All these questions is a multitude, and it just has you go up and down on this list, and then side to side. It just makes you not think one-dimensionally. If we're talking about water, we can do some really interesting conversions. So you just follow it as best you can. You go over, then up and down. Anyhow, so if we're going to go from kilograms to centimeters cubed, let me just erase all this stuff here, just so you can see it. Oh, I can't erase it. That's too bad. We're going to go from kilograms, which is this one right here, and we're going to try to get it into centimeters cubed. But we have to, probably the best way to do it is to make it into a straight conversion for decameters and then move it over this way, because it's a jump in 2 different directions. So we know that 8.5 kilograms equals, and here's where we have room for our rough work, 8.5 decameters cubed. We know that there are 1,000 centimeters cubed in 1 decameter. We have 8.5 decameters, and if there's 1,001, there must be 8,500 or 8,500 in 8.5. So this is a multiplication question. So I went one too many zeros. Hold on. 8,500. There we go. Now, the next one is grams, and we're already at centimeters right here. This is centimeters cubed, and if you look, that is a straight conversion. We know that 1 gram of water will fit in 1 centimeter cubed of space, so it will be the exact same. My smartboard is really not working well today. And on our last one, we now have to take 8.5 kilograms and put it into liters. But if we look where we started, way up at the beginning, there's my kilograms, there's my liters. Anything that goes in this straight line is a straight one-to-one conversion. So this will simply be 8.5 liters. I'm going to do one more, and then I have to call it a day. We've had enough time to study for this, and you'll do as best you can. Let me erase what I can off of here, which isn't much, because I took a picture of this and pasted it. Okay, so we have 2.35 tons, and remember, that's our elephant. It's a well, it's a baby elephant, but it's a big weight. And we're going to take that and move it into kilograms. We're only moving one place. Remember, the number is 1,000. So there are 1,000 kilograms in 1 ton. If you have 2.35 tons, and there are 1,000 kilograms in 1 ton, obviously this is going to be a multiplication question, and we're going to multiply this by 1,000, which would make this 2,350 kilograms. So now we're right here. The next conversion is to decameters, and as we see with our chart, that 1 kilogram of water will fit in 1 decameter cubed of space. So this will be a straight conversion using the number we just had, 2,350. And lastly, we want to go over to kiloliters. Now, with kiloliters, we would have to go over to find out how much that would be in millimeters cubed and then up. But if you remember, our question started in tons. And a ton of water will fit in 1 kiloliter in a unit of capacity. So this is a straight conversion back to our original. 2.35 tons is 2.35 kiloliters. Anyhow, practice with your sheets. Take a look at it. I'm sure you're going to do much better tomorrow.